Mars, the red planet, has captivated our imaginations for centuries. Its rusty hues, visible even to the naked eye, whisper tales of ancient waters and the possibility of life. Today, Mars stands as the next great frontier for human exploration, a potential second home for our species. Dr. Scott Solomon, an evolutionary biologist, has dedicated his career to understanding the challenges and opportunities that await us on this alien world. His work offers a glimpse into the future of humanity, a future where we might one day call Mars our home. But the journey to Mars is fraught with challenges. The red planet is a harsh and unforgiving world, vastly different from our own. From the crushing weight of its low gravity to the relentless bombardment of cosmic radiation, Mars will test the limits of human resilience and ingenuity. Overcoming these challenges will require a deep understanding of the scientific, technological, and ethical dimensions of space travel. We must equip ourselves with the knowledge and foresight to ensure the success and sustainability of any future Martian colony. The journey to Mars is not just about reaching a new planet. It's about pushing the boundaries of human knowledge and exploring the very essence of what it means to be human. One of the most significant challenges facing Martian settlers is the planet's weak gravitational pull. Mars's gravity is only about 38% as strong as Earth's. While this might seem like a fun novelty at first, the long-term effects on the human body could be detrimental. Our bodies have evolved over millennia to thrive under Earth's gravity. Our bones, muscles, and cardiovascular system are all finely tuned to operate within this gravitational constant. Exposure to prolonged periods of low gravity can lead to muscle atrophy, bone density loss, and cardiovascular problems. Astronauts aboard the International Space Station, which orbits Earth in a microgravity environment, experience these effects firsthand. They must engage in rigorous exercise routines and follow specialized diets to mitigate the negative impacts of low gravity. The challenges posed by Mars's low gravity will require innovative solutions. Scientists are exploring a range of countermeasures including artificial gravity environments, advanced exercise equipment, and specialized diets to help Martian settlers maintain their physical health. Understanding the long-term effects of low gravity on the human body is crucial for the success of any future Martian colony. Beyond the challenges of low gravity, Mars presents another invisible threat: radiation. Unlike Earth, Mars lacks a global magnetic field and a thick atmosphere to shield its surface from harmful cosmic rays and solar flares. This constant bombardment of radiation poses a significant risk to human health, increasing the likelihood of cancer, radiation sickness, and other health problems. Long-term exposure to Martian radiation could have severe consequences for colonists, potentially affecting their DNA and increasing the risk of genetic mutations. Protecting Martian settlers from radiation will be paramount. Habitat designs will need to incorporate radiation shielding materials, and colonists may need to restrict their time spent outside of these protected environments. Developing effective radiation shielding technologies and strategies for minimizing exposure will be crucial for ensuring the health and well-being of future Martian colonists. Mars is a planet of extreme temperatures, its climate far harsher than anything experienced on Earth. The average temperature on Mars hovers around -80 degrees Fahrenheit or -62 degrees Celsius, but temperatures can plummet to -200 degrees Fahrenheit or -129 degrees Celsius at the poles during the Martian winter. These frigid temperatures pose significant challenges for human survival. Exposure to such extreme cold can lead to frostbite, hypothermia, and even death. Designing habitats that can maintain comfortable temperatures amidst these frigid conditions will be a significant engineering challenge. But it's not just the cold that poses a threat. The Martian summer, while still chilly, can see temperatures rise to a balmy 70 degrees Fahrenheit or 21 degrees Celsius at the equator. These temperature swings, combined with the planet's thin atmosphere, make thermal regulation a constant concern. Section 5. A thin veil of air. The Martian atmosphere's suffocating grip. The Martian atmosphere presents another formidable obstacle to human colonization. Composed primarily of carbon dioxide with only trace amounts of oxygen, the Martian atmosphere is incredibly thin, about 1% the density of Earth's atmosphere at sea level. This thin atmosphere has several implications for human survival. First and foremost, it cannot support human respiration. colonists will need to rely on technology to generate breathable air within their habitats and spacesuits. The thin atmosphere also provides little protection from meteoroids. Unlike on Earth, where most meteors burn up in the atmosphere, small meteoroids can reach the Martian surface, posing a potential threat to surface structures. Section 6. Evolution's next canvas. How Mars could reshape humanity. The challenges of living on Mars will not only test our technological prowess but also push the boundaries of human evolution. Over time, natural selection may favor certain traits in Martian settlers, leading to physiological and genetic changes. Dr. Scott Solomon explores this fascinating possibility, suggesting that Martian colonists, exposed to generations of lower gravity, higher radiation levels, and different atmospheric conditions, might evolve distinct characteristics compared to their Earthbound counterparts. These adaptations could manifest in various ways, from changes in bone density and muscle mass, to alterations in skin pigmentation and eye function. Over many generations, these adaptations could lead to the emergence of a new human species, specifically adapted to the Martian environment. Section 7. Engineering our Martian future. The technologies we need to survive. Surviving on Mars will require a technological leap forward. We'll need to develop innovative solutions for habitat construction, life support systems, food production, transportation, and more. Habitat design will be crucial. These structures will need to be self-sustaining, providing breathable air, temperature regulation, radiation shielding, and waste recycling. 3D printing and other advanced construction techniques may be employed to create these habitats using Martian resources. Food production on Mars will require innovative agricultural techniques. Hydroponics and aeroponics, methods of growing plants without soil, will likely play a crucial role in sustaining a Martian colony. Section 8. Planetary protection, safeguarding Mars from earthly contamination. As we venture to Mars, we must consider the ethical implications of our actions, particularly the potential contamination of the Martian environment with Earth-based life. Planetary protection, the principle of preserving the pristine nature of celestial bodies, is paramount. Strict protocols will be necessary to prevent the accidental introduction of microbes from Earth to Mars. These protocols may involve sterilizing spacecraft before launch, carefully managing waste, and conducting extensive biological surveys before human exploration. Contaminating Mars with Earth-based life could jeopardize any chance of discovering indigenous Martian life and compromise the scientific integrity of future research. Preserving the Martian environment for future generations is a responsibility we must embrace. Section 9. Human rights beyond Earth. Ethical considerations for Martian settlers. The establishment of a Martian colony raises profound ethical questions about the rights and freedoms of those who choose to make Mars their home. What rights and responsibilities will Martian settlers have? How will governance and decision-making be structured in this new society? Ensuring the well-being, autonomy, and self-determination of Martian settlers will be essential. Creating a just and equitable society on Mars will require careful consideration of human rights principles and their application in this novel context. Section 10. The moral imperative. Balancing ambition with responsibility. As we stand on the cusp of interplanetary travel, we must proceed with a deep sense of responsibility. The challenges of colonizing Mars are immense, but so are the potential rewards. The pursuit of scientific discovery, the expansion of human knowledge, and the possibility of ensuring the long-term survival of our species are all powerful motivations. However, we must balance our ambition with a deep respect for the ethical dimensions of space exploration, protecting the Martian environment, ensuring the well-being of future colonists, and addressing the potential for exploitation are all crucial considerations. Section 11. A future written in the stars, the promise and peril of Mars. The journey to Mars represents the next giant leap for humanity. It's a journey fraught with challenges, risks, and uncertainties, but it also holds the promise of extraordinary scientific discoveries, technological advancements, and the expansion of human knowledge and presence in the cosmos. As we embark on this grand endeavor, we must heed the insights of scientists like Dr. Scott Solomon, who remind us of the profound biological and ethical considerations that will shape our future on Mars. By carefully considering the challenges and opportunities that lie ahead, we can strive to create a future where humanity becomes a multi-planetary species, one that explores the cosmos with responsibility and respect.